Okay, so today we're going to talk about Python objects, how Python represents data. Boop. Here's what we're going to learn. We're going to understand how data is stored in Python. There are 5 things that I'm going over. And I'll break down the vocabulary and stuff. I'll also make this PowerPoint available so that if you want to look at where I got my information, you can do that as well. Those websites at the bottom also have some examples that I found instructive. I included a few in this PowerPoint. Anyway, let's go on to rule number 1 about data storage. Everything is an object. So what is an object? An object is a single piece of data stored in a program's memory at an address. Addresses can only store one object each. Some objects are so big that they take up several addresses worth of space. You can think of it kind of like this this mailbox sort of thing, where there are different sized mail slots for different sized packages. It's similar with objects. So it could be like an integer stored there, it could be a string stored there, whatever. When are objects created in Python? Whenever a literal value is used or a class constructor is called. Now that's very jargony. I'm going to break it down. So a literal is when you explicitly write a piece of data. So you've done this before. It's when you make a string with quotation marks. It's when you write down a number. It's when you use a Boolean, true or false. So whenever you write down the piece of data, you're creating an object that's stored in memory. Now, a constructor is when you make an object using the init, initial function of a class. So like when we've done float, converting an integer to a float, or for more complex classes, which we've used a little bit, like with velocity and stuff in our games, that's a constructor, making an object. So here's some examples here at the bottom, how the object is created. Here's some examples using literal values. So the part of the code creating the object is the string literal Bob, or the integer literal 58. These over here are just variable names that are referencing the objects. So the objects are the actual values, the actual things, pieces of data. So in memory, these would be stored at different addresses. And the addresses are usually written in hexadecimal, which is base 16. Don't worry about it too much. And then over here, here's some examples with constructors, same thing. The value is stored in memory when you use the constructors. All right, rule number 2. Every variable is a pointer to an object. So consider this code example here. We have x equals 5 and y equals x. Now the question is, how many objects were created? You can take a guess if you'd like.
2.
Just 1. Whoa. Okay, so remember, objects are only created whenever a literal value is used or a class constructor is called. So the only place that that happens is when the number 5 is written. So the symbols x and y are actually pointing to the same value in memory. That's why these variables can be called pointers, because they just say where the object lives. So variable x points to the address for 5. Variable y also points to the address for 5.
That's crazy.
Crazy, man. So this will become important later on, why we have to know that pointers are a thing. Okay, rule number 3, some objects are immutable. What the heck does that mean? Mutable means changeable. Think of mutate or mutations. The following object types are immutable, meaning you can't change them once they're created. Integers, floats, strings, and tuples. You haven't used tuples. They're basically like arrays that you can't change. When you make a variable point to a new object, the old one remains at the old address. So let me show this with a little visualization here at the bottom. And we'll be using this ID function to see the address of the objects in the code. So here's some Python that was executed. We have x equals 1. So 1 is the object created. And then this line is just printing out the address where 1 lives. So x is pointing to 1. Okay. Now if I say x is now pointing to 2, notice that the address changes because 2 is at a different spot in memory. And the 1 is still at its previous spot. There's just nobody pointing to it anymore. It's just chilling there. So different languages handle this differently, getting rid of old data. It's called garbage collecting. In C, you actually have to say, let's get rid of that old data in your code. But in Python, the developer doesn't have to care. Python just does it for you. Hooray. Thanks, Python. So that's what I mean by immutable. Once this 1 was put in memory, it didn't get changed. It's still there. They just put 2 in a new spot.
Well, I was kind of curious about the immutable.
Yeah. So yeah. So the original 1 never changed. Still there. You had to make a new object when you make a new assignment. Okay. This stuff may seem like pretty abstract, and like you may think, why do we have to know all this stuff? I'll explain a little bit at the end of these rules why it can be useful, but let's just keep going. Okay, rule number 4 of 5, any object can be copied. Okay, so blah, blah, blah. The example is the most useful part of this. So let's say I had a list of 2 names, and then I made a second list that was equal to the first list. Now, in that previous example we saw for rule number 2, when I set y equal to x, there wasn't a new object created. They were just pointing to the same value, right? So it's the same thing in this case. When we set list 2 equal to list 1, there wasn't a new list created. List 1 and list 2 are both pointing to the same thing. So if I change something on list 2, that also gets changed on list 1. Now that can be a problem. What if I want list 1 to stay the same and list 2 to change? So this is where copying comes in. Now the way to copy a list is to use the list constructor. That way, list 2 has the same values as list 1, but they're at a different location in memory. So if I change something on list 2, list 1 stays the same because they're stored separately as separate objects. So that's why copying can be useful. And that's why we have to remember about the pointerness of objects and the immutability of objects as well. Okay, last rule, and then your brain can take a break. Okay, last rule, you guys already know this or have seen this before. I just wanted to include it here. Variable names should follow PEP 8 standards. PEP 8 is just Python style. So good style is to use snake case for variable and function names, and then Pascal case, which is where you capitalize the first letter of each word for class names. Now we haven't written a whole bunch of classes yet. We wrote one for velocity that one time when we did the Pong activity. And remember that variables are case sensitive, meaning that capital name and lowercase name would be different. And then not allowed for variable names is using reserved keywords that Python already uses. Like you can't set true equal to 5. Sorry.
Oh,
You can get away with that in C and other languages because they don't care as much. Anyway, you can't start a name with a number, just like when naming babies. That's also not allowed. You can't use an operator in a name, just confusing, no spaces. So that's the last rule as far as storing data and stuff goes in Python. Okay. So after going through this little presentation, I'd like you guys to go take this quiz. I'll copy this link and put it in the chat so that you can just click on it. You don't have to type it in. Any questions on any of the slides? So these are the the 5 rules of data storage in Python, and most other languages follow this sort of pattern too. Any questions before we finish?
not really.
Okay, cool. I'll stop sharing my screen and stop